Hello, my name is Victoria Doherty, and now that you have a grasp of what are significant figures, we're going to talk about calculations with significant figures and why it's important to keep those in mind. So again, I'm going to remind you that when we're doing calculations with significant figures and measurements, we have a limit as to what we know about the measurement. And our final answer in a calculation has to reflect either the precision or the certainty of the measurements we use in those calculations. A lot of times we're going to be doing multiple calculations. And so it's important to remember that you round at the end. So when you're doing step 1, step 2, step 3, whatever, you're going to have to make a mental note how many significant figures you must maintain after each corresponding calculation. And then again, the importance of this. Why do we care? Well, if you step on the scale and it reads 127.2 pounds, and then you do an average of this with 3 or 4 different pounds, obviously, or measurements, obviously your scale only goes to one number past a decimal. So if you do 3 measurements, you divide by 3, you're going to get an irrational number, and you can't report more numbers past what your scale is capable of measuring. And that's why we care about it. All right, so let's go over some of the rules because they're different depending on what you're doing. And so the first one we're going to talk about is calculations with multiplication and division. Okay, so in this particular rule, when we report our final answer, you have to have the same number of significant figures as your answer with the fewest number of significant figures, or I'm sorry, measurement. And so here's a very simple measurement. We have calculated this distance that has 8 significant figures, and we've calculated, I'm sorry, not calculated, measured the time using 3 significant figures. We're going to do a simple division, okay, divide this giant number by 137 seconds, okay, and then we're going to get this answer here. Now again, the smallest number of significant figures is in 137 seconds. And so when we do our math, we can't report the answer we get. We have to round this to 3 significant figures. And so when we report the final answer, we can report it like this because we remember, since there's no decimal here, these zeros are not significant. So this number only has 3 sig figs. If that makes you uncomfortable, then we can report it as a scientific notation, 5.76 times 10 to the 1, 2, 3, 4, 5. Oops, times 10 to the 5 meters per second. Both of those values have 3 significant figures. And so depending on how you report it, depending on what's one of your answer choices, you need to be able to recognize that both of those answers have 3 significant figures. Okay, here we have a set of 3 measurements. Our first measurement has 3 significant figures, the next one has 2, and the last one has 4 significant figures. So when we stop the series of calculations, the final answer we report is limited by the second calculation that only has 2 significant figures. We multiply all 3 of these together. This is the number in our calculator. We have to remember that we have to stop here because why? Because this measurement limits us. It's not as certain, it's not as precise as the other 2 measurements. So we don't know what's after this 2. We have no idea what's after this 2. So we can't report it. Oh, that's weird. They both turn out as 52. That's a coincidence, by the way. Anyways, so when we report this value, we have to stop here. Okay, and so we're going to round, which means that last number stays the same. And the final answer we report has 52, has 2 significant figures, and we report 52 cubic centimeters. Now, let's do a problem. Report the value with the correct number of significant figures. So we're going to do this math. We're going to take 2.34 meters. We're going to multiply it by 14 meters. And the number we get on our calculator is 327.6 square meters. Okay. Again, We look at this first measurement, 3 significant figures. We look at the second measurement as 2 significant figures. And so this measurement will limit what I can report. So we need to stop at 2 significant figures. I'm going to rewrite this with 2 significant figures. And now remember, I don't have a decimal here. This is an implied decimal. So this last 0 is not significant. I'm going to throw my unit on there. Some of you may find this uncomfortable. So if it makes you feel better, we can go ahead and convert this to scientific notation. But both of these values have 2 significant figures. Okay, because again, that 0 does not count. Okay. Let's go ahead and let's look at what happens when we do subtraction and division, addition. And so now we're changing the rules a little bit. Okay. We're going to say now we're limited by the certainty of the instrument. So what does that mean? If I take these 2 masses and I add them together, these were obviously done with 2 different scales. Cheap scale, expensive. Okay. And so the cheap scale can only measure one number past a decimal. And so when I add 23.3 to 51.269, I can't add the 69 because why? I don't know what's after that 3. Right? My scale stopped after the 10th place. I don't know if I'm adding that 6 to a 0. I don't know if I'm adding it to a 3, a 9, an 8. No idea. So we're going to do our math. Certainty stops at the 10th place with this particular measurement and calculation. So I'm going to drop these last 2, round at the end. And that leaves me with an answer with 3 significant figures. Now, again, it's only a coincidence that this has 3 sig figs and so does this. And we're going to see the next example where our final answer has a different number of significant figures than any of our measurements. Okay, so again, I have 237.62 joules. I'm going to subtract 12.2 joules. And if I set this up like I did the previous example, I have 237.62 joules, 12.2 joules. This is where my certainty ends. This is the value that I get. But I have to end where my certainty does. Okay. And so for this particular answer, I'm going to get 225.5 joules. And notice, my final answer has 4 significant figures. My first measurement has 5. My second measurement has 3. But it doesn't matter because in addition and subtraction, the number of significant figures does not determine your final answer. Your certainty determines your final answer. Okay, so let's do a problem with this. What is the average mass of these 3 samples? So to get the average, I add all of them up and I'm going to divide by 3. So let's go ahead and do it. So I have 0.2414 grams, 34.90 grams, and 22.489 grams. I'm going to add all those together. I'm going to take a quick mental note. And what I see here, this is going to limit my certainty. So when I add all of these up, I get this number, 57.63040. I'm going to make a mental note because this is where my certainty ends. Grams. The next calculation is when we do an average, we add everything up and then we divide by the number of samples. So in this particular case, we have 3. So now I'm going to divide by the number 3. Now, 3 has how many significant figures? An infinite. Why? It's a counted number. So now I know I have 3 samples. 1, 2, 3. We didn't use it as measurement. We counted it. So it's not going to influence my final answer. So when I divide all of those by 3, the answer I get is 19.2101333 grams. I know based on my rules of addition and subtraction, I have to end there. So when I finally report this value, it's going to be 19.21 grams. Again, remember, counting numbers have an infinite number of significant figures, right? It's not a measurement, it's a counted number. So they do not influence my final answer. But if we do a combination, so the next problem, the next example is combination. So we have to remember our order of operation, PIMDAS, which is pretty simple because I put some parentheses here. So the first thing we're going to do is we're going to do this addition problem. So we're going to add 6.012 grams to 7.3 grams. Keeping in mind that my level of certainty ends here. Okay, and so the 13.2 would be my final answer, as if this is where I was stopping, but that's not where I'm stopping. The next thing is we're now going to divide by this number, this measurement. So now I have to pay attention that after I did this addition step, my final answer would have 3 significant figures, which of course, the second part is a division step. So now the number of significant figures determines how many are in my final answer. The second value of 5.0025 mils has 5 significant figures, but that doesn't matter. Okay, 3 significant figures is going to limit. Notice I'm making a mental note and I'm waiting till the end to round. This is the value that I get. Only 3 of these values are significant. And so this is the final answer that I must report. 2.64 grams per milliliter. And so again, it can be confusing when you're doing multiple calculations. Biggest mistake is you forget that just because we're switching rules here, addition and subtraction, you don't always get the same number of significant figures, and your final answer is one of your measurements. Multiplication, division, fewest number of significant figures determines how many sig figs are in your final answer. So let's do this final calculation. What answer should I report when I'm doing this calculation? So again, we're going to follow our order of operations. We're going to do this calculation first, and it's 21 minus 19.63 grams. So the answer I'm going to report has to stop here. I report my final answer, and it's 1.370. And so again, I have 2 sig figs here. I have 4 sig figs here. But after I'm done with the calculation, how many significant figures can I report in my final answer? Only 1. Because why? Because that's the certainty. I do not know what's here. I do not know what's here. So I can't report the 0.370. I just can't. Okay. And so what I end up doing is now the second half of my calculation, I'm going to divide this by 0.33. Oops, I forgot my units. Okay, keeping in mind that I have 1 significant figure. Yeah, sure, I have 2 sig figs here, but who cares? Because when I finally do this calculation, again, the number on my calculator is going to be 4.151515 grams per milliliter. I only have 1 significant figure in my final calculation. So the only answer I can report is 4 grams per milliliter. I know some of these rules can be confusing. The only thing that's really going to help you is by practice, practice, practice. Okay. If you have any questions, you can always go to the TRC. They have great student helpers there. Or, of course, you can always come ask your instructor. Good luck to you guys. Bye-bye.